Folks, hello and welcome to your week one discussion post. What I thought I would do is take 2 or 3 minutes here just to set this up to make sure it's clear what we're asking for in this discussion post. And also, if you have never used Desmos before, just a couple of quick things within that tool. That's a great online graphing tool. It'll be very helpful for you in the course here if you have never used it before. So in this discussion post, first of all, the first thing that we've asked you to do here is access the Desmos User's Guide. It's here. It's a PDF. If you click on it, obviously it'll open up for you. And it's a good little tool to have as you go through the course. What we are looking for here is we're looking for 3 different graphs. Each one builds off either y equals 1 over x or y equals 1 over x squared. And we've asked you to modify it based on some conditions here. So what I thought I would do is I would just like to set up problem 2a for you here, and just to make sure that this is clear, and then again just a little more on Desmos if you've never used it before. So what we've asked you to do is we want you to start with either y equals 1 over x or y equals 1 over x squared, and then we want you to modify that function within a Desmos window such that you have one vertical asymptote and no horizontal asymptote. So I'm gonna switch over here to Desmos, and I'm gonna graph y equals 1 over x. And notice here that I have both a vertical asymptote here at x equals 0, and I have a horizontal asymptote here at y equals 0. And remember, so again, what we're looking for here is one vertical asymptote and no horizontal asymptote. So what you've got to remember about asymptotes is how they happen. And you know that we have vertical asymptotes where the denominator is equal to 0. So if I look at the base function here, y equals 1 over x, it makes good sense that since 0 makes the denominator 0 here, makes the function undefined, you clearly have a vertical asymptote here at x equals 0. You also have a horizontal asymptote here because the degree of the numerator is less than or equal to the degree of the denominator. So if you look at the degree of the numerator, since you have a constant here, the degree of the numerator is 0, and obviously x is being raised to the first power, and so the degree of the denominator is 1. So since the degree of the numerator here is less than the degree of the denominator, you're already showing a horizontal asymptote here. So what I want to do for that first problem, let me just go back here and remember what we're doing here. I picked this one. So I want to retain the vertical asymptote, but I do not want a horizontal asymptote. So what I need to do to this function, I need to modify it somehow such that I increase the degree of the numerator to the point that it is greater than the degree of the denominator. So one thing I could do, if I just added x, notice that I have now created a situation. If I were to simplify this, I would have to multiply x by x over x to have a common denominator here. And so this, in fact, would actually give me a condition where the degree of the numerator is greater than the degree of the denominator. And one more time, just 1 over x plus x. If I wanted to add these two together, I would make a common denominator where I'd multiply x by x over x, again, which is multiplying by 1. So I would have 1 plus x squared over x, and then the degree of the numerator here would be greater than the degree of the denominator. Just to make a point here, we still retain the vertical asymptote here. These points here are not asymptotic in the sense that what we had with 1 over x. What you can see here is that the function is getting very, very close to y equals 0, but it does not touch y equals 0. However, when I add x here, the fact that I have a minimum value on this side of positive 2 and a minimum value on this side of the vertical axis of minus 2, that does not represent an asymptotic relationship. It is just minimum values or local minimum values on this side of the function and this side of the function. So just to make sure that everybody's clear, I wanted to show what it is we're looking for here when we modify functions to create the situations in A, B, and C, and then also to use Desmos. If there are any questions on this, please let me know, and hope you have a great first week. Thanks.